Hello folks, welcome to my YouTube channel. I know it's been a while since I last uploaded any video. So what I'll do in this video is first talk about what I've planned for this channel, and then we'll proceed with the whatever contents of this video is. So I've already covered about how you can create your apps using Kubernetes, like how you can take your application and then put it into different containers and orchestrate in platforms like Kubernetes. So that is already discussed and it's on a playlist on my YouTube channel, so you can check that out. In this video, what we'll cover is what should be the architecture for your applications, right? So you are familiar with the steps, you are familiar with how you can build images, you can deploy images, that you're familiar with. But what you need to understand is like how can I actually architecture my solution, like what should sit at the front, how should I distribute, how should I distribute my application, different services, how they should communicate with each other. So those are a lot of the other things which you have to think about before you can actually take your application into any meaningful production. Right, so you just don't need to understand that okay, this is how you build images. You also need to understand how to actually build a solution out of it. Right, so this is the first step, this video, which will talk about what microservice architecture is. So we'll understand like what is the all the hype behind how to design different applications in such a way. So what we're going to cover in this video is basically, first of all, what are microservices, just to start off. After that, we're going to cover how it is different from traditional models of app development. So we already know how we build applications right now. So in the monolith form, we just have one application and all the files are within it. So how microservices is different from the traditional models of app development. After that, a very important question is that do I really need a microservice architecture? Because even though I've understood what an architecture is and like how it is framed, but do I actually need it for my solution? Right. So what is the parameters on which you judge that your solution requires what kind of architecture? So that is what you're going to discuss in this question. After that, all of that is done, and now once you're sure that you want to build a microservice application, so how do you go about starting an architecture for it? Right? What are the steps you follow? What are some common guidelines that you should keep in mind before setting out to build a architecture on your own? So you'll understand that those are guided by design patterns. So as you know that a lot of software development is done on design patterns. So we have to understand like what design patterns are most relevant in the case of microservices, and I will discuss a few here, and we'll also learn how you can use them effectively to structure applications. After that, we'll also discuss about some common architectures first of all. So what I'll do is I'll take some architectures of the internet and one of my own as well, and then you'll see how all of the learnings that we have in this video can be translated into real life. And we can also take a look at what technologies are used for each of the different components of your microservices architecture, because that is how you'll relate your learned theory to actual practice. If you know, okay, this part of the application is built using such software, so you have a better understanding of like how these things are actually built. Right. And finally, I'll walk through one of my distributed applications, which is built using Dapper. So we'll see how I have structured my application in different parts, what is the guidelines I've followed. And it's a very basic idea. It's not the entire architecture of its own, but it'll just still help you to get some idea of how you can communicate between different services. What are the steps? What are the options that you have? So yeah, let's just jump right in. So first of all, we'll talk about what microservices are. Right. So as you can see, I have put a quote here from IBM India's documentation. So it's just very simple understanding that it has some loosely coupled parts. So you have an application which serves different purposes. So what you do is you take all the different purposes, which is generally called separation of concerns. So you separate your entire business idea into different parts which function independently. Okay, so say for example, if you're talking about a restaurant service, so you'll have an order service which deals with the orders. You have a customer service which deals with all the customer data and stuff like that. So you have very clearly distinguishable blocks in your entire business idea, right? So those blocks, those are the services. So a loosely coupled arrangement of these services is what microservice essentially means. So you're not talking about one single application, you're talking about different services working independently and they're working together, talking to each other, sharing information. That is essentially what microservices are. And all of these different services are independently deployable. So you can deploy them separately. Like as we already talked about how you can build containers for each of these services. So each of these containers can run on different pods separately, and you can scale them and do all sorts of stuff independently of each other. That is the idea behind it. So you can also look at two of the bullet points I have. So it says they can have their own technology stack, including a database and data management model. So yes, these services are different containers. So you can write them in any languages you want, right? So you don't have to worry about having a common language between all of these services. Say for example, if I need any fast application, I might write it in C++. I mean, if I need some Java specific libraries, I'll use Java for the second service. So that is not really, it's a choice of yours. So you don't have to worry about that. So yeah, so these are the different services. They communicate using REST API. So basically you have what you call different services communicating together, and then they also have their own databases if you want. We'll also look at one of the design patterns that tells you about how to manage databases with your services. So we'll look at that in the future. Okay, so what it essentially enables. So what does a microservices architecture essentially enable you to do? That's what the question is, right? So as I told you, you can scale these services individually as per demand of a business need. For example, if you have different containers with different functions, if you want to scale one of those at a much greater rate than the other, you can do that because they're not dependent on each other and they're not part of the same system, right? Easy and fast modifications to your code without affecting other services. That is also very essential. For example, if you have to add a feature or say modify any part of the code. So if imagine if your application was part of a huge monolith, right? So if you had a very big set of applications and many services all bundled together. So in that case, if you had to modify any part of your code, that would have required you a lot of trouble, right? So say for example, this is A, this is B. All right, so this is some of the parts of your monolith application. Now say for example, I want to add some modification in the part E. Now I understand that part E is also intertwined and connected with all of the other parts, right? They're sharing libraries together, they are in the same language. So how can I guarantee that any changes I make in E are not going to affect any other changes? We can't be sure of that, right? So for example, if I modify E, if I replace this block with another block, right? So if I take out E, modify this E and then put it back in, so it might break other services, right? So we're not really sure. So in that case, we'll have to have a lot of checks to understand, okay, whether I could make this change or not. On the other hand, imagine if you had all of these services independently deployed, and say I have E here, and now all they are doing is they are communicating using APIs. So I have to make sure that any modifications I make to E should be consistent with my previous APIs, right? So it doesn't matter if I change the language at all, or if I change libraries or anything I want to do, I can do it here. But what I have to make sure is that the API with which it communicates with the rest of the services, that doesn't change, right? Or if it changes, I should also make it known to all the other services. So that is how having a very distributed kind of set will actually help you in making modifications really faster. And if you want to add a new feature, say if you want the F feature to be added, right, you can just independently create that as well and start communicating with different services. So you don't have to actually modify the entire application at all. That is one of the very essential things which it enables you to do. And yeah, it is a gateway into the world of cloud native, which allows you to run your application in any cloud environment. Yeah. So if you are structuring your applications in a form of microservices and in form of different containers, you don't have to worry about, taking it to some specific platforms. You can deploy it anywhere on any cloud provider and stuff like that. So it is like a gateway into the world of cloud native. This is one of the first steps that you do for your application in order to make it, runnable in any cloud environment, right? So this is essentially what microservices means. Now, a really important question here: do I really need a microservice architecture? So first of all, let's just imagine that you have an application, you have a project of your own, and you want to explore whether or not you should start off with microservices, right? So I'm not talking about a case where you're building a POC or something like that, but you're just thinking about your own personal project. Okay, should I start building a microservice architecture or not? So the top advice is, if you're just starting out, you should not choose microservices as the first option, right? So because microservices in itself is like usually designed for applications which are very huge. Like if you have hundreds of services running and they're talking to each other, and you can't manage all of this in a monolith. Like for example, if you can't, deploy changes and stuff like that. So in that case, you should go for microservices. But if you're just starting out, if you don't have a lot of services, like 3 or 4 services or something like that, you should not do microservices, because essentially what it requires is DevOps. You may have heard about what DevOps is. I may also try to explain it in some other video. But essentially what I'm trying to tell you is that, say for example, if you actually decide to build microservices, in that case, you'll have to have different containers. First of all, this is the minimum requirement. So if you have 3 services, you're going to have 3 containers, right? Now, how are you going to design your solution in such a way that all of your application code, for example, I have some application code for A, right? This is my editor. I have some application code for A. Now, any modifications I make in this application code for A, when I commit this, it should automatically build an image and deploy. Right? So these are some additional steps that I need to follow, right? And the same is true for B and for C. That is one of the things, that any changes I deploy, any changes I commit in my local IDE, I need some kind of a pipeline, I need some kind of a setup that will take this code, build the image, and then run it in your cloud environment, right? So that is an additional step that you need to do. This is one of the things. Apart from that, what you need is monitoring, right? So how do you get the logs for A, right? It's running in some cloud environment. So how do you know exactly how this is going to affect you, right? So for example, let me just see that, for example, let's just say that I have an A application, right? Now I want to know what the logs are for it. So is it functioning as I want it to? Like, are the requests that I make to A actually reaching the place or not, right? That is one of the things. Apart from that, I want to know that all the requests that I make between A, B, and C, how are they being traced? For example, if B was at failure, so B was not accepting a request. So I need to understand what the different points of failures are as well. So all of these things require also a lot of extra configuration at your end. So unless you are actually required to do this, you should not prefer starting off with microservices, at least. That is the idea, right? Okay, the best way to know when to transition, how do you actually judge that you have to transition now, is that, say for example, if you're actually feeling all those problems, right? So for example, if you are actually understanding that, okay, I'm not being able to make small changes fast, right? I'm having some trouble, like the other problem we discussed earlier, that the e-service, right? So if that is some of the situations you're actually facing in real life, that okay, I want to modify one of the features, but I'm not able to do it without having to look through all of the code. So if all of those problems are actually being faced by you in real life, that is when you know that, okay, I have to now transition to microservices. But if all's working fine, then I don't think that you should explore microservice as the first choice, right? And again, in situations where you have to just demonstrate an idea in the form of POC, for example, if you have some competitions which require you to submit an architecture following the microservice principles, right? Or you just have to design some idea for a client that, okay, this is how your application is going to look like in the future. In that case, all of this knowledge will be really helpful for you. Right now. All right. Now we'll go over to the next part. How are microservices different from monoliths? Right. So this is really essential. So a lot of the time, people who have approached me, they have asked me that, okay, I have an application I've built, but I need to have a microservice architecture for whatever reason. So they have heard the term a lot. They have heard about microservices a lot, but they are not really sure how to go out building it on their own, right? So they feel that this is some kind of a new world, and that they'll have to rewrite their application. They have to go through a lot of steps in order to transition to that world. But this illustration which I have on my screen right now is one of the very best which I can think of. Like, if you look at it correctly, it's not much different, right? Whatever application you have in the monolith, it's just the same at microservices. The only difference you see here is that earlier, all of these different blocks, right? All of these different blocks are part of one single enclosure, you can call it, right? One single bubble. But here in microservices, all of these blocks are deployed independently, as you talked about earlier. So that is just the only difference. You don't have to rewrite any of your code, right? It's just primarily a task of restructuring your solutions. Right? So if you already have a service, if you already have an application, what you have to figure out is how can you structure it in different services, right? How can you break it off into different parts? Usually, if you are developing in a very good format, you already have separation of concerns in place, right? So for example, if you have an application which performs multiple tasks, you already have different files for different functions for the different tasks. That is what separation of concerns means. So if you have such an architecture already, then it's really very easy to transition to microservices, right? So you just take all the different parts of different functions and then create new containers for each of them. Just that's simple, right? So you don't have to create an entire application to fit into this world. And also, if you have an architecture like that, you can also transition very quickly to a microservice architecture. So this is all you want to understand about the difference between monolith and microservices. There are other very essential differences as well, but I prefer that you understand at the very basic level what the difference is, right? You can always find out more differences and like the point-wise terms on the internet on other videos as well. But I just want to have a very intuitive understanding of what the difference actually looks like, right? So okay, so we have understood that this is the main difference. Now, what other modifications in your code do you want? For example, if you are trying to transition, you're just taking an application which you have, say for example, Java application, and if you're trying to switch it to microservices, what are the possible modifications that need to be done, right? So off the bat, if you look at the diagram here, what you will see is that earlier they were part of one bubble and now they are part of different bubbles. So the primary thing which I need to take care of is how do they communicate between each other, right? So for example, if I have the pentagon here and I have the triangle here, right? So how are these two going to communicate? That's something which I have to figure out, and that is something which I can either put inside the code when in the code of this applications, or figure out some other way, right? So that is one of the things which we understand should be a modification to your existing code, right? That is one of the things. And how you actually do it is, again, like there are a lot of technologies which enable you to do this. Some of the very naive way to do it would be to put it inside the code. For example, you can, in the Pentagon's code, I'll put say a network call to the IP address of the triangle application, right? So that is how you can communicate in a very naive way. But there are also other solutions which allow you to not modify the code at all. So you just have very slight modifications in your application, then you can easily connect with all the different services. So that is one of the possible modifications which you want. And another modification which you can prefer to do is that once this is out of the monolith, you can try to implement all the different blocks in different languages, depending on like whatever might be best for the use case, right? So these are just the two modifications which I feel might be necessary if you're transitioning from a monolith to a microservice architecture. All right. So yeah, let's just now talk about design patterns. Really important. So you have an understanding of what microservices is, like how they're deployed, how different from monoliths and stuff. But how do you actually go about? What are the guidelines that you follow if you have to build your own architecture? So, for example, if I ask you that, okay, give me an architecture for designing and microservice architecture. So sorry, that sounds weird, but yeah. So you need to have some ideas, some principles about how you can actually go about building your application in the first place. So let's just talk about one of the very common and very important patterns, which is the API gateway pattern, right? So if you look at the diagram here, you can understand that you have the clients on the left side here, right? You have the clients here, you have a browser native app, and you have a traditional web server side application, right? And then you have one API gateway. Now, what this API gateway does is like a single entry point. So you can imagine your application with different services sitting on some cloud server. So let's just imagine that, say you have this some cloud provider here, and you have multiple services running inside, right? So this is A service, this is B service, C and D. Now, any request that a client makes, right? For example, if I'm a client here, I need to make some request. So this request will have to be communicated to different services as well. For example, let's just say I'm a customer and I want to find out, say I'm an Uber customer, and I want to find out what the nearest Uber is and what the rating for the driver is. So in that case, I'll have to connect to at least two services, at least two. So one will be the location service. Say A is a location service. So it will tell me that, okay, considering your current location, these are the 5 drivers which are closest to you. And then this one also need to talk to the driver service, which will hold all details about driver. Say B is the service which holds details about drivers. So any call that I make needs to connect to multiple services, right? So for the client application, whatever application I have right now with my client, that needs to have a knowledge of all the different services in the location, or it is much better, it's much convenient to have a single entry point, right? So for example, if I have somewhat of a let's just say if I have a API gateway, which is a single entry point, all my requests will be made to this gateway, right? So for example, if I'm having a mobile application, I'll just make a hit to one of the endpoints here in the gateway. Now this gateway is going to redirect all of my requests to different services inside of it. So this gateway has knowledge of all these services, right? So this is one of the applications of using a single entry point application gateway, API gateway. You can also add multiple other type of things on this API gateway. For example, authentication, right? So this API gateway might authenticate the user and then authorize you to access other services inside the application. So that is one of the things, right? Another benefit of using an API gateway would be protocol translation. For example, if you look at this video, you can see that the review service is using AMQP, right? And the other service is using REST services. So the knowledge of all of these things is not necessarily required for the client, right? You don't need to know what protocols your services are going to use. Your client doesn't need to know about that, right? So all those translations can also be done within the API gateway. Apart from that, say for example, inside your application, you are now restructuring all of your services. For example, A, B, C, D, I want to break up D into 2 different services, say D and E, right? If I want that to happen, the knowledge of this should also not be with the client, right? The client doesn't need to have all this knowledge. So having a kind of an abstraction layer for your microservice is what it serves as, the API gateway, right? So you can restructure your application, you can change the way the function happens, but the API gateway will make sure that all the requests that the client makes is redirected in a very controlled manner, because API gateway is under your control, right? So you understand that, okay, this is the change I have done and this is how I'll now redirect all the requests. right? So this is one of the things, right? All right, so this is a very common, what do you call, a design pattern. I'll also put in a link for this pattern on my YouTube channel description, so you can check this out in much more detail, and you can also look at examples of how this thing is built. So we'll just touch upon it now, not go into very much detail right now. And also API gateway is something that I'm thinking of discussing in a future video in much depth. So I'll talk about what the actual technology stack should be, like what you should use for API gateway. At least my recommendation is not a requirement, of course, but I'll just tell you that what I usually prefer when I try to build an API gateway. And yeah, that is all about it. The next pattern is database per service. So we already talked about having inclusive databases for different services in the first slide, if you remember. So yeah, what does this actually mean, right? So for example, let's just imagine a scenario where I have two different services again, like the order service and the customer service. Now the order service needs to have data for the different orders that are placed, right? So it needs to have like the timestamp, what customer placed the order, what is the quantity, all that stuff in some database, right? And the customer database will have all the information about different customers, their locations, their cards, their stuff like that, right? Transaction history and stuff. Yeah. So what is the best way to devise a database that serves these purposes? So you might imagine that I have two different tables for it, right? Or two different servers entirely. So usually what we prefer in microservices is to have the service and the database coupled together. So here you can see that we have the order service and here the order table, and they are as a part of one of the things, right? They're just part of one entire block here. So now this order table is only accessible through the order service API. So for example, if the customer service API needs to get some data from this order table, it will just call this order service API. Then this order service code is going to fetch whatever data they want and send it to customer service API. Now, you might think, what exactly is the benefit for such an arrangement here? So right off the bat, you can think of solutions like, say, for example, if I want to modify my database, right? If I want to modify the structure, if I want to modify the way I query things, so all of these things need to be changed, right? If you have direct access to this database for all different services, for example, customer service could directly query from the order database, say for example. In that case, any changes in the structure of my application, structure of my database, or any changes in the way I want to query, that needs to be propagated to all the different services which are going to use it. So for example, I have customer service here, I might have a different service X here as well. That is also having some work with this order table, also needs access to this table. So in that case as well, I'll have to propagate this knowledge of this change to all the different services, which is not really desirable, right? So I need to have, it is much better in that case to have just a single API. So any modifications I want to make in my order table, I can propagate that change to this particular service only, the order service. Now the order service is going to take care of any changes, and then it will serve the same API. So any of the other services who want to access it just need to hit this API. That's all. Right, so that is one of the very important benefits of having such an arrangement here. Right. So apart from that, other benefits can be that, say, you have different requirements in your application, right? Somewhere you need a NoSQL database, somewhere you need a fast indexing database, something like that. So this gives you a flexibility to have different database servers for different services. Say order service might require a MongoDB database, right? Customer service might require Redis or some other kind of database, right? So this kind of an arrangement will help you to very easily implement such solution, right? So that is also one of the very important benefits of using this kind of design pattern, right? As the third design pattern we're going to talk about is the circuit breaker. Now I just want to let you know what some small details about what circuit breaker is. We're not going to delve much deeper into this yet. So the basic idea is this. Say for example, if I have a service A, I have a service B, and I have a service C. Now usually maybe take a situation that say B is facing a lot of latency. Due to some reason, it is not able to service requests very fast. For example, now A has some requirement for service B, so it's making some calls to service B, and now service B is taking a lot of time to respond. So in that case, what happens is, essentially you can say that service B is down, right? It is down, so it's not able to service requests practically. Now there are threads in A which are dedicated to calling this service B, right? So they're using system resources and they are being stalled, like they're still waiting on the response from service B. So in that, essentially, B going down is also taking A down with it, because since these threads are still waiting on getting response back from B, the A service is not able to effectively service its own requests, which are coming to itself, right? So it's some kind of a cascading effect. That is also one of the scenarios. Apart from that, you can also imagine that, say, C is also some requirement for service B, right? So now, since B is down, it is not able to send those requests to C, and so C is also getting affected, right? So it's kind of this way in which entire microservice architecture can potentially fail if any one of the services fails, right? So what you want here is that such a kind of arrangement that, say, for example, if B was down, then, say, after some timeout period, some kind of intelligent way of knowing that, okay, since B is down, whatever requests are now coming to B will be turned back immediately. They don't have to wait for it. For example, say a thread in A makes some request to B, right? So now, if we somehow determine that, okay, B is down right now, so in that case, this request will be immediately returned as a failure. So A won't have to wait on B, right? So that is one of the ways in which you can actually prevent such kind of situation. So this is also one of the very important design patterns. Usually people implement this in like production environments, but yeah, it's good to know about it right now. All right, now let's talk about some example architectures, right? Okay, so we learned about what the API gateway pattern was and what database per service pattern was as well. So here you can see is like a real life architecture diagram of how this looks like. For example, you have a mobile app here and you have a browser. So you have two different clients, right? So there's an API gateway which is serving through a REST API. And now this API gateway is going to talk to all different services. There's an account service, there's an inventory service, and there's a shipping service, right? So this API gateway is forwarding all requests from this mobile app to all these different services. So for the mobile app, it's just only one point of contact, which is this API gateway, right? And now you can also see that for account service, it's using an account database. For inventory service, there's another database. So all of these databases are coupled together. Right? So this is database per service pattern in use here. So this is how you can design some kind of a restaurant or any online store pattern. So if you're tasked with designing an application for any online store using microservice pattern, this is the kind of pattern which you can employ off the bat, and then you can make modifications as you move forward. Another thing I want to talk about is this. This is another kind of scenario use case. So for example, you have multiple clients. There's one API gateway. This box is your cloud, whatever cloud you're using, right? And now this API gateway is going to forward all requests from your client to different services. Now here I have service A in Python. Service A in Python. I have to change the name. I forgot to change the name here. So imagine this is service B, and imagine this is service C, right? So service B is written in Node, service C written in Go. So you have different services written in different languages, as you mentioned, and they all are communicating with each other as well as to the database. They all have their own databases as well. Now you can see I have written here service mesh. So service mesh is a way of enabling communication between different services. Remember, I talked about there being multiple ways in which you can ensure communication with different services. One of the ways was adding all the required code into the application itself, right? For example, one way of communicating between service A and service B was I add some code, additional code apart from a business logic into service A and service B, which allows them to communicate. There are other ways as well, as I mentioned. So one of the ways is using a service mesh. So service mesh makes it very simple to communicate between different services and also track logs between different services, metrics as well. So we'll talk about service mesh sometime in the future later on. I just want to give an idea of what this thing is. So it's not really very hard to communicate with different services, especially when they're less in number at least. Yeah, so this is another idea of an architecture which we can design for our clients. After that, let's talk about the app walkthrough. For the app walkthrough, let's go to the browser and let's check out this particular repo which I have. Yeah, so this is not exactly built using any common patterns. I just wanted to have a more idea of how services communicate with each other and what the separation of concerns looks like. All right, so here this is the architecture diagram for my application. So you can see I have three different services. There's an event service, there's a messaging service, and there's a controller, right? So you can skip the idea of the controller for now. It's just a way I wanted to implement an MVC architecture using a microservice pattern. So for example, this is kind of an API gateway. You can imagine this as an API gateway. So what happens is all requests that are made are first made to this controller. And now this controller will forward requests to all the different services. right? So for example, if you want to create an event, now this controller will send this event, so then send this request to the event service, right? This event service has its own state store. It has its own database store, which is using Redis right now. So yeah, this is the idea, correct? So this is the brief way in which you can, develop your application. Now, what is new here is Dapper. Now, Dapper, as I mentioned, that you already have a lot of different options for enabling communication between services. Dapper is one of them. Dapper is an open source software which you can use to, very easily communicate with different services without having to know their actual IP addresses or their locations. Plus, it also gives you some more functionality, which is additional state store. So Dapper on its own configures whatever state store you want to use without any, it gives you a lot of options. Like you can take Redis, you can take other MongoDB as well. So you can take multiple databases and then you can use it. I have a video on Dapper on my YouTube channel, which you can check out. So that is also one of the tools which I used in order to facilitate communication and other, kind of function calls between different services. That is how Dapper works. So yeah, this was the idea behind all the microservice activity which you see. So hopefully the next time you go ahead and see any architecture diagram for any microservice, you understand it better. You know what those things are. You know why service mesh is required, what tools like Dapper do, what they're trying to achieve, what are the common challenges that people face, right? And what are the main patterns that you can use to develop your own solutions, right? So let me know if you have any doubts or if you have any questions regarding any architecture, and I'll be happy to help. For now, that is all. And hopefully we'll be talking about all these concepts in detail later on, like each of the different parts. And I'll see you then. Thank you so much.